Alright, so you want to know the speed of sound? I'll help you out. Now, me and an associate figured this out on a football field, and we have Texas A&M Stadium Kyle Field to help us figure this out, or to demonstrate. So, I stood here on the goal line. Well, I had a buddy sit on the 27-yard line, roughly around here. Now, I had him sit here because 27 yards is 25 meters, very roughly. And I had him yell, and I started a stopwatch and stopped it. I started it when I saw his mouth move, stopped it when I heard his voice. Super tiny amount. And that was 0.07 seconds. Now, I will have my associate, Kristen Mendoza, explain the math right after this. I am just giving you a little demonstration. Now, then I stayed on the goal line. This entire time, I was on the goal line. Now, I had him go to the 55-yard line, which is right here. Technically speaking, right here. Now, since while he was right here, all the way, and I was all the way over here. Now, for speed of sound, that's no biggie. Covers that super fast in about 0.15 seconds. Now, that's super fast. This is just super fast from the goal line to 55 yards. Imagine running that fast. Now, 55 yards, like I said before, is roughly around 50 meters. I wanted to keep this almost simple in meters, but I had to convert it to yards since I was on a football field. Wasn't too bad. Now, I had my associate, while I was still standing on the goal line, travel 109 yards, so roughly just one yard off of the edge of the football field. Off the edge of the football field. Now, this took a little longer to travel, but still under 1/3 of a second. It took 0.29 seconds from the sound of travel from the other end of the football field all the way to the first goal line. Now, that's crazy. And so now here's Kristen explaining the math behind it. Super simple. Now, one thing I did forget to mention was that each time measurement was over different days, so it was 3 different days of timing during lunch. It was Monday, Wednesday, and Friday during lunch, just when we had some time to go out there and test it out.
Okay, so today we will be calculating the speed of sound, and I will be explaining the math that Enzo did, and due to budget cuts, we do not have reading cards, so I will be reading off of the phone. So, to start off, to find the speed of a moving object, use the formula speed equals distance divided by time. So all we have to do here is plug in the distance and times that Enzo got out on the football field using the first set of numbers he got, which were 0.07 seconds to travel 25 meters. So all we would do is rewrite the equation as speed equals 25 divided by 0.07, which ended up being 357.12 meters per second. So moving on to the next set of numbers of 0.15 to travel 50 meters, plugging these into the equation, we get 333.33 meters per second. And using the last set of numbers, he gathered 0.29 seconds to travel 100 meters, getting us to 344.83 meters per second. The numbers we gathered on the 3 different days were explaining why the speed is not consistent throughout the test due to factors such as wind, humidity, dust, and other weather.
Weather conditions.
Yes.
Other weather conditions.
All right.
Yeah, I talked in the other takes, but she didn't think those were sufficient enough.
Yeah, they weren't good.
Because you laughed a bunch.
Yeah, it took a while. Definitely more than one takes. All right, so that is how you
calculate the speed of sound.
Yep, that's it.
Do that.